57! Oh, best prime number! It's the only prime number that has two factors, where 1 is not equal to 1. A huge thanks to Brian for sponsoring this video. Good morning, fellow mathematicians! Welcome back to another video on the hard exam series. And what we're going to talk about today is what I really wouldn't consider to be a hard exam, but a subscriber showed it to me and I found it quite curious and interesting. It's a Massachusetts Institute of Technology exam, entrance exam, for the mathematics faculty from 1869. Nice! Also, by the way, engineering clock finally available. Limited to 200 pieces and only for 1.5 months available. We already sold quite a few pieces and it seems they are going to be out of stock really early. So yeah, get yourself one if you don't have one already. Now, we're going to take a look at this exam. A subscriber sent it to me. He sent it to me as a means of showing me that there's some kind of other competitive math problem out there. It's an entrance exam whatsoever, because people kind of compete to get into their favorite university. And also it's an exam, so he thought it would be cool to combine both things that I'm striving for right now on this channel. And I think that's a pretty cool thing. And if you take a look at it, I also have it here on my laptop. It's just that this thing came to me in, well, image form. Yeah, it's a pretty small one, and OP said that this actually consists of 3 or 4 parts: algebra, arithmetic, geometry, I think, and a few other things. But he only sent me the algebra one because he couldn't find the other ones online. It seems that the Massachusetts library, so the online library, is not available anymore. Like the archive for the exams is, I don't know, it just doesn't work anymore right now. I can't access the link he sent me. He told me that he can't access it anymore too. But yeah, this is basically all that I've gotten. I found it quite interesting and I would like to solve it with you guys today on an improvised session here on my blackboard. Other than that, a few more information on this thing. So it was from 1869, and you see there are only 7 exercises here, and those exercises are pretty easy looking at it at first glance. I don't know if they are really easy because I'm just going to solve it here on the blackboard, but they look really easy at first sight. And I think, I don't know, maybe it was hard back in the days, 1869, because there was no Wolfram Alpha around. People these days have a lot of access to information, internet, many resources out there, books, etc. But back in the days, maybe this was really a high thing to learn, even in schools. So I don't know about that. If you are from the 1869 something and you are down there in the comments watching this video, please tell me if this was hard for you. Maybe Leonhard Euler is going to comment. No, I think he was born a bit earlier. But yeah, it consists of 7 exercises. I can tell you how many people failed, etc. It's an entrance exam that was written like 1.5 centuries ago. But it's still quite interesting to me. And yeah, you can find the picture or the link basically to this thing down there in the description, at the top of the description, and you can solve it together with me. We are going to go to the blackboard right now, and then we are going to see how this turns out. Alright, this is one of Papa's improvised sessions basically, and yeah, we're going to start off with the first exercise. I have already written out the hello kitty kitties, the first 4 exercises, and the other 3 are going to come after a little cut. I'm pretty certain, like I said before, I'm pretty confident that I'm able to solve all of those here, just improvised. We are going to dive right in. We are going to start with the really shitty approximation for E. This is even worse than the approximations here on my clock, so yeah. Sucks pretty hard. So E is equal to 8, meaning it's the 3rd power of 2. So I think this is what we need here at some point because we have the 3rd root. So if we were to plug all of this in, we are going to get, so this is 8 minus square root of 8 plus 1 is 3, because square root of 9 is 3. So we get 3 plus 2. This makes 5 overall in here. Plus, and then we are going to get 8 minus, and then 2 to the third power, and then the third root is just going to give us 2 times, and this is going to give us the square root of 4, meaning this is 2. Overall, we are going to get 8 minus 5, 8 minus 5, plus, and this is going to give us 6, 12, and then 12, yes, 12, exactly, plus 12, and this is going to be 15. And I hope this is correct. Yeah, I hope this is correct. Like I said, improvised here. Let me take a look at it again. It's going to give us 5, and then this is 3, and this go. Yes, seems good to me. Next, we are going to simplify this, if I remember correctly. Simplify the following expression. Exactly. Okay, let us take a look. So this gives us 3a minus, this is negative b, and then minus, this is going to give us minus 2a, positive b. Oh, doesn't that is going to cancel out. And then negative and negative is positive, so plus a minus b, giving us 2a overall, 2a minus b. Yes, this is actually pretty okay. While editing the video right now and putting in little pictures of the exercises, I noticed that I did a completely wrong exercise, and yeah, and instead of an a plus b, I had an a times b down here in the denominator. So I have to redo this thing, and thanks to my engineering clock, I know that it's 9:30 in the evening, so let's redo this thing real quick. Okay, this is still improvised, so nothing did change. I have to work through it. And we have to divide by a plus b instead of a times b. I can put the outtake on the other channel if you want to see the process there. So, yeah, I think the best thing would be to do some kind of polynomial division, because if I just factor everything out, it's going to be a huge mess. So let me try to do some kind of polynomial division. So a plus b is our x, you could say, on the first factor. So we want something of the form a plus b times, what do we need to multiply it by such that we get this expression? So we need a 3a here, definitely, plus some kind of x times b. And now we are going to see if it turns out nicely, so if we get some kind of remainder or not, if it's just a polynomial basically. So this gives us 3a squared, just what we need, plus x times ab plus 3ab plus xb squared. Now we need x to be equal to -1. This gives us 2ab, which does not work out. Not with this one. So when dividing by this one, we are going to get a remainder. This is not what we want. So let's try the next one. A plus b times, okay, now we don't have a coefficient here, so we need just a. And then negative, it's going to be negative, definitely negative x times b. Let's do it like this yet again. We are going to get a squared, what we need, negative xab, and then positive ab, and negative xb squared. Now we need x to be equal to 3 such that it fits, and then we get -2. Exactly, this works. So we need a 3 right here. So this is the decomposition of our polynomial, you could say. So a plus b and this 1 over a plus b is going to cancel out, giving us 3a squared plus ab minus b squared times a minus 3b, leaving us with 3a to the third power. This can be reduced, okay, this is the highest power we have. And then minus 9a squared b, and then plus a squared b, so this gives us -8 here. Yes, and then -3ab squared. then negative ab squared, so it gives us negative 4ab squared, and positive 3b to the third power, leaving us with 3a to the third power plus b to the third power, as it seems. And then we are going to get negative 4ab, and then what do we have? We have 2a plus just b, right? And this should be it. I'm just a human being, and if I mess it up, then I mess it up. Next up, when I saw this while writing it out or while checking the paper in itself, this just screams for the difference of two squares down here. So we are going to rewrite something. This is x to the 6th power plus a squared x to the 3rd power y. And down here we are going to have x to the 3rd power and the whole thing squared minus a squared y and the whole thing squared. And this is the difference of two squares down here, meaning this is going to provide us with x to the 6th power plus a squared. We have x to the 3rd power as a common factor here. Let me factor it out real quick. Maybe this makes matters easier. X to the 3rd power and then plus a squared y, then over, yeah, obviously it makes matters way easier. So down here difference of two squares is x to the 3rd power minus a squared y, and then x to the 3rd power plus a squared y. And obviously this is going to cancel out, this is nice. And this is going to give us x to the 3rd power over x to the 3rd power minus a squared y. Those are really good elementary school exercises. I'm going to erase everything and then put less free exercises. Let us continue. Now we need to simplify this as much as possible. So what they basically want from you is just basic algebra skills. So basic calculative algebra skills, I suppose. I mean, back then they didn't have Mathematica and stuff like this, so just makes sense that they could do everything handcrafty. So yeah, it's kind of fun, to be honest. Now, yeah, we are just going to add those fractions together and see what we get. I mean, down here, obviously, difference of two squares in the common denominator. So what we have is up here is a squared plus b squared plus a minus b. Okay, this is a plus b squared. Oh goodness. Sophomore stream. No, not sophomore stream. Freshman stream. I just now did it. And then a minus b squared over, and this here is going to be the difference of two squares. So a squared minus b squared. And this whole thing over, so complex fraction action going on. A plus b, whole thing squared, minus a minus b, whole thing squared over a squared minus b squared. And yeah, this was obvious from just taking a look at it, taking a sharp look. They are going to cancel out, and now I'm going to write everything out and see what I get. I hope I don't run out of space. So up here we are going to get a squared plus 2ab plus b squared plus a squared minus 2ab plus b squared. That is going to cancel out. And down here we are going to get basically the same thing, just with so those are going to cancel out, all the a squares and b squares, and down here we are just going to get 4ab. This becomes positive. Yes, 4ab, meaning this is 2a squared plus 2b squared is going to be 2 times a squared b squared. So 2 over 4 is 1/2. So a squared plus b squared over 2ab. And I think this should do it. What a nice formula, looking good. Now, we want to solve for x at this, and I'm going to expand the fraction yet again, because we are going to have the 16 as the common denominator, which is going to cancel out. We can multiply both sides by 16 then, because it's not equal to 0 exactly. So we are going to get a times this is going to give us, this is equivalent to saying we have 24 times x minus 32. And this whole thing over 16 then, which is going to cancel out, I'm going to write it out. And then expanding this by 2, so negative 12x. And then positive 10 is then equal to 3x minus 1 is equal to 3x minus 1 over 16. Multiplying both sides by 16 gives you that. That's equivalent to saying we have 24x, so this gives us 12x. Minus 22. Minus 22 is equal to 3x minus 1. This is 9x. That's equivalent to saying we have 9x. And then is equal to 21. Yes. And now divide both sides by 9 gives us 21 over 9. Prime factorization gives us 7 over 3. X is equal to 7 over 3. And I'm not going to check if that's okay. I think it should be okay. You're going to get a rational number out. So they also need to know about rational numbers, which is pretty dope. Okay, as a mathematician or striving mathematician, you should know what rational numbers are with regards to equivalence clauses and stuff like this. So next up, last up actually, we are going to take a look at the system of equations, and I think I'm not going to go for matrices and stuff like this. I'm just going to eliminate the y, meaning that's equivalent to saying we have, let me see, I'm going to expand up here by negative 3 and down here by 5, giving us negative 21x. And then positive 15y being equal to negative 72. And then down here we are going to get 20x. Oh, that's actually pretty good because we are going to get x out of this whole thing. Then negative x, doesn't matter. And then obviously minus 15y, this is what I wanted. I wanted to eliminate this, is equal to 55. We are going to add both of those and are going to get out negative x. They are going to cancel out, is equal to negative 17, meaning x is equal to 17. And now we can plug this in. If I plug it into here, for example, we are going to get 4 times 17 is 68. 68 minus 3y is equal to 11. That's equivalent to saying we have 3y being equal to 57. Oh, best prime number. I love 57. It's the best prime number just because it's the only prime number that has 2 factors where 1 is not equal to 1. 3 times 19. Okay? Crazy good. Prime number, best one. Y is equal to 19. 3 times 19. That's a Grothendieck prime, by the way, if you didn't know already. Meaning, this solves the question, and now back to the table. It was fun. Alright, we are back. I didn't check if my answers are correct. I don't know. I hope they are correct. But other than that, it was kind of easy to solve these questions here. I can only say they were easy. After I really know if they were right. If I wasn't right with anything, then they probably weren't easy. But I suppose that I would have been able to solve this thing here, even in an improvised way, just like I did here. And to my surprise, even though it's from 1869, everything here is nice and readable. So even the radicals are here. You might notice that you know what they are going to encapsulate. For example, the square root of e plus 1. You just know by the parentheses that this is meant. And yeah, basically the notation used here is pretty much up to date. So I could read through it really nicely. There was not a problem at all while reading through this. And yeah, pretty good questions. Pretty good standard basic algebra questions that each and every high schooler, for example, should know how to solve. And I think it's some cool stuff, and I would really like to know if this was like the really hard shit back in the days. I can't really tell you, but I hope you did enjoy this little video that still belongs in the exam series in some way. But before we actually end the video, I would like to thank today's sponsor Brilliant.org for sponsoring yet another video here on this channel. Today's exam has been considered as challenging, if you believe it or not, back in the 1800s, and math enthusiasts were competing to get into MIT with their solutions. If you are also interested in clever maths and competitive math problems, I encourage you to try out Brilliant today. Besides their awesome selection of various problems in maths, geometry, physics and many more topics, Brilliant provides their users with a dedicated competitive maths course, which fits right into this video if you ask me. It covers the most basic and advanced tricks to cleverly finish math problems for many branches of mathematics, such as algebra, calculus and probability theory. So if this feels like it's something for you, make sure to check out the link at the top of the description. With it you are going to get completely free access to Brilliant, and the first 200 people to use the link get 20% of an annual premium subscription, which is a great deal considering how much content they have on there already. So yeah, make sure to check out the link and support the channel this way. I thank you guys for watching. If you did enjoy this video, please like, subscribe, recommend channel if you like. Don't forget to engineering clock. It's pretty amazing. I love this thing. And yeah, what else should I say? Other than that, I'm wishing you guys a flammable day, and don't forget to check out Flammy too. Also for other various maths content that's going to come out 6 times per week. Ciao!